Hello everyone, this is Prasant here to give you some information about solar space cooling of building. Introduction. Solar space cooling is a method of using solar energy to cool the buildings. It involves harnessing the power of the sun to drive cooling processes, reducing the reliance on traditional cooling method that consume electricity or fossil fuels. For example, as you can see in this figure, with the help of the sun radiation, it is used to cool the building. Have a look towards the types of cooling systems. There are five types of cooling system: solar powered air conditioning, solar absorption cooling, solar desiccant cooling, radiant cooling, and hybrid systems. Now let us study in detail about them. Solar powered air conditioning. This type of system utilizes solar energy to power conventional air conditioning units. Photovoltaic panels generate electricity from sunlight, which is used to run the compressors, fans, and other components of the air conditioning system. As we can see in this figure, the rays falling on the photovoltaic cells, these are the photovoltaic cells, that is solar panel, and through this solar panel, the air conditioning is working. The second one is solar absorption cooling. Absorption cooling system use solar thermal energy to derive the cooling processes. Solar collectors capture heat from the sun, which is used to generate cooling through an absorption refrigeration cycle. This cycle typically involves a refrigerant and an absorbent working fluid which interact to produce cooling. As we can see in this figure, there is a solar collector, a storage tank, a regenerator, absorber, evaporator, condenser. So it forms a cycle where the heat is rejected and cooled, which helps in cooling the building. And the third one is solar desiccant cooling. Desiccant cooling systems utilize solar heat to regenerate desiccant materials, which are used to remove moisture from the air. Solar collectors heat the desiccant material, enabling it to absorb the moisture. The dehumidified air is then cooled by passing it through a heat exchanger. As you can see in this figure, with the help of solar panel, desiccant materials are being heated up, which absorbs the humid, and the dry air is then condensed and passed through a heat exchanger to the rooms, which cools the building. The fourth one is radiant cooling. Radiant cooling systems leverage solar shading, reflective surfaces, and cool roofs to minimize the heat gain and create a comfortable indoor environment. This system works by reducing radiant heat transfer between the building and its surroundings, thus reducing the needs of mechanical cooling. As you can see in these figures, we can also use the reflective glasses on the walls, which reflects the sun rays and protects from heat. The last one is hybrid systems. Hybrid solar cooling systems combine solar energy with conventional cooling technologies to optimize the performance. For example, a hybrid system may integrate solar thermal collectors with a vapor compression chiller, allowing solar energy to supplement the cooling provided by the conventional chiller. As we can see in this figure, the sun rays are collected by the solar panels where the photovoltaic cells creates electricity. With that electricity, this house load is working, where the cooling is done with the help of certain refrigerator or AC, air conditioners, etc. And with it, this electricity is also thermal electricity is also provided, which enhances and optimizes the performance of the air conditioner or the cooling technology. Now let us look towards the advantage of solar space cooling of buildings. Renewable energy. Solar energy is a renewable resource that is abundant and freely available. By utilizing the solar power for cooling, you reduce the reliance on fossil fuels and contribute to a cleaner and more sustainable energy in the future. As well as it is a cost saving. Solar space cooling can lead to significant cost saving over time. Once the initial installation costs are covered, the operational cost of the solar cooling system are lowered compared to the traditional cooling methods that rely on the electricity or fuels. Energy independence. Solar cooling system allows buildings to become more self-sufficient in meeting their cooling needs. By generating electricity or thermal energy from the sun, buildings can reduce their dependence on the electrical grid or other external energy resources. Re- Remote applications. Solar cooling is particularly advantageous in the area without access to reliable electricity grids. It can be used to cool buildings and structures in remote locations. Reduced environmental impact. Solar space cooling helps reduce greenhouse gas emissions and environmental pollution associated with conventional cooling methods. By utilizing clean and renewable solar energy, we can contribute to mitigating climate change and improve air quality. Long lifespan. Solar cooling systems are designed to be durable and have a long lifespan. Solar panels can last for several decades, requiring minimal maintenance. This longevity contributes to the overall cost effectiveness and reliability of solar cooling systems. Resilience. Solar powered cooling systems can enhance the resilience of buildings during power outage or disruption in the electrical grid. Government incentives. In many regions, governments offer financial incentives, tax credits, or grants to promote the absorption of solar energy systems, including solar cooling. These incentives can help reduce the initial investment cost and make solar space cooling even more economical and attractive. Similarly, let's look towards the disadvantages of solar space cooling of building. Initial cost. That is, the upfront cost of the installing solar cooling systems can be higher compared to the traditional cooling systems. Weather dependency. It rely on the sunlight to generate power or thermal energy. Therefore, their performance is influenced by weather conditions. Space requirement. Solar panels or solar thermal collectors require adequate space for installation. Depending on the size of the building and the cooling load, a considerable surface area may be needed to accommodate the solar panels. Energy storage. Solar cooling systems that rely on photovoltaic panels may require energy storage systems such as batteries to provide cooling during non-sunlight hours or on cloudy days. So energy storage adds additional cost and requires regular maintenance. Technological limitations. While solar space cooling technologies have advanced significantly, they may not be suitable for all building types and climates. Factors such as building design, orientation, and cooling load should be carefully considered. Maintenance and repairs. Like any complex system, solar cooling systems require periodic maintenance and ensure optimal performance. Components such as solar panels, inverters, and cooling equipments may require cleaning, inspection, and potential repairs. Integration challenges. Retrofitting existing buildings with solar cooling system can be more challenging compared to incorporating them during the design and construction phase. Uh, Limited cooling capacity. Some solar cooling technologies, such as absorption cooling, may have lower cooling capacities compared to conventional cooling systems. These limitations may make them more suitable for smaller scale applications or buildings with lower cooling demands. Now let us look the application where solar cooling system is used. First and the foremost is the residential building. It can be implemented in homes and apartment complexes to provide energy efficient and sustainable cooling. Commercial buildings, office buildings, retail stores, hotels, and other commercial spaces can benefit from solar space cooling. Industrial facilities. Solar cooling can be used in industrial settings, including factories, warehouse, and manufacturing plants. These facilities often require cooling for equipment processes or employee comfort. Educational institutions, schools, colleges, and universities can utilize solar cooling to provide comfortable learning environments for students and staff. Healthcare facilities. Hospitals, clinics, and medical centers require cooling to maintain suitable conditions for patients, medical equipment, and staff. The data centers. Data centers generate significant heat due to the operation of servers and computer equipments, so solar cooling can be integrated into data centers to assist in managing the cooling load. The last is remote and off-grid application. Solar space cooling is particularly advantageous in remote areas or off-grid locations where the access to electricity or traditional cooling infrastructure is limited. So solar cooling can provide us sustainable and independent cooling solution for remote homes. Now let us see the requirements for solar space cooling of a building. Solar resources. The solar resources are the building's location, the availability of the sunlight and its intensity throughout the air will impact the feasibility and effectiveness of solar space cooling. Similarly, building design and orientation. Factors such as building's orientation towards the sun, shading elements, and available roof or facade space for solar panels will influence the design and installation of solar cooling system. Now, cooling load assessment. Then, similarly, energy efficiency measures, system sizing and integration, regulatory compliance, maintenance and monitoring, financial consideration, expert consultation. So these are the requirements for the solar space cooling of building. Now, in the conclusion, solar space cooling offers numerous advantages as a sustainable and energy efficient method of cooling buildings. By harnessing the solar energy, it reduces reliance on traditional cooling methods that consume electricity on fossil fuels, contributing to cost savings, energy independence, and environmental benefits. Solar cooling can be applied in various settings, including residential, commercial, and industrial buildings, as well as remote or off-grid locations. Factors such as solar resource availability, building design, cooling, load assessment, system sizing, and integration, maintenance, regulatory compliance, and financial considerations all play a crucial role in the successful deployment of solar cooling systems. It is recommended to consult with the professionals experienced in solar cooling system design and installation to ensure the specific requirements of the building are met effectively and efficiently. With careful planning and implementation, solar space cooling can provide sustainable and comfortable cooling solutions, reducing energy consumption and minimizing the environmental impact. So this was all about the solar cooling system of the building. So thank you very much.